Hello, my name is Leonelino Beas, belonging to the mechanical electrical career. The, the theme of the exhibition is making precision signal chain design easier. Introduction. Efficient signal acquisition is fundamental to application varying from industrial process control in measurement to high-speed communication in imaging. Across this broad range of applications, the ability to match the proper component to the task is essential for creating a signal chain fully able to meet performance requirements on the lowest possible cost. Optimizing instrumentalities signal chain for the cost performance. Performing this balance of cost in performance becomes even more important with the expected proliferation of enabling embedded sensors system feeding the Internet of Things IoT. Without device counts expected to the number in the tens of billions, saving achieved a average stage of the signal chain translated into the significant saving overall. For desired pooling and effective signal chain main devising a specification of individual components with the aid it stage to meet the target performance level of the signal chain as well will some application require the base with the highest possible specification. Figure 1. The site can often use more cost-effective components that nevertheless compare of the signal chain with the required level of performance on the functional. Figure 1. A performance analog component include an analog digital converter and the multiplexer enabler, circular hadron coupled to measure magnetic fields with the highest performance possible. In small basic form, and the signal acquisition circuit wall ideally comprising only one component, an analog digital converter at ADC to the digital analog input signal from sensor on there of the source for any practical application. However, the real-world signal characteristics preclude such the simpler approach in use for the requirement for signal conditioning, including amplification in theory 2. For application, use active sensor additional components such as digital analog converters. The UIC precision voltage reference in amplifier are new on the front end to provide sensor with their current excitation current voltage levels. Fury 2 prior to their conversion of typical analog signal chain required conditioning to compensate for small signal input similarly on their signal characteristics unique to its application. Signal conditioning typical sensor in the traducer produces small amplitude signals with amplification. Amplification The signal will use of only a portion of the field dynamic run on the ADC. Most likely result is low of the fundamental due to limited ADC resolution and high-tuning impact of converted quantization of error. Consequently, the site is typically new on a new from an AFU amplifier stage to a encrypts this span of the input signal to match the full dynamic range of ADC. Theory 3. Differential amplifiers to our analog Davis ADH476 Fury integral lasers to emit resistors in output capillary to the ADC interface. Interface requirement helps simplify the size of the signal chains with this difference in input requirements.
What is signal conditioning? Signal conditioning is the manipulation of a signal in a way that prepares it for the next stage of processing. It is one of the most important components of a data acquisition system because without optimizing real-world signals for the digitizer in use, you cannot rely on the accuracy of the measurement. In a nutshell, signal conditioning takes a signal and makes it easier for your DAC device to measure. Types of signal conditioning. Here are some examples of common signal conditioning types, their functionalities, and examples of when you may use them. Amplifiers increase the input signal amplitude. For low voltage output signals, an amplifier can increase the resolution of your measurement. Attenuation decreases the input signal amplitude. If an output voltage is more than 10 volts, this can be used to decrease the output to fall into the range of a DAC device. Filtering rejects unwanted noise within a certain frequency range. It can be useful to remove frequency ranges or bands from vibration measurements. Excitation is required for many types of transducers and can refer to either voltage excitation or current excitation. Any sensor which changes its resistance based on the phenomenon being measured will need to be provided an excitation source. Other types of signal conditioning include linearization, bridge completion, isolation, and cold junction compensation. Types of sensors. There are many different types of sensors. Some measure voltage or current, while others measure resistance or capacitance. To achieve the best measurements, understanding the signal conditioning needs for each measurement and sensor type is paramount. For example, the most common sensors to measure temperature are thermocouples, RTDs, and thermistors. A typical signal range for a thermocouple is -80 to +80 millivolts. If you have a 16-bit digitizer with a range from -10 to +10 volts, you will only use 0.8% of the range of the ADC and will not have as much accuracy as possible. Thus, amplification could be used to improve the measurement performance.
Signal conversion, signal conditioning circuits, coupled-side amplifiers and filters are designed for the sole purpose of delivering an output signal to the input of an ADC. Consequently, the complexity and performance specifications for those different in components that deliver largely from the characteristics in requirement of the ADC. A costly high precision amplifier is a necessary expensive and the signal chain required only to provide a relatively low resolution conversion of the low changing signals purified ADC such of the maximum integrity max 14115 can operate in rectangular mode, eliminating the new for precision voltage referring for signal conversion.
signal converter? A signal converter is a device that converts signals from sensors to industrial current signals. There are multiple types of signal converters: analog to digital converters, digital to analog converters, frequency converters or translators, voltage converters, frequency to voltage converters, voltage to frequency converters, current to voltage converters, current loop converters, and charge converters. Each of those types of converters have a different ability. For example, an analog to digital converter samples analog signals and converts them to a series of digital values. Digital to analog converters convert digital numbers into corresponding voltage or current levels. Frequency converters or translators convert or scale input frequencies to specific output frequencies. Though they have their differences, each have a similar goal in mind, which is specific output frequencies. Though they have their differences, each have a similar goal in mind, which is to receive one type of signal and output another type of signal. Performance specifications for signal converters differ by type, but they all include channel specifications, accuracy, resolution, signal specifications, mounting options, and the user interface. For more information about how Radwell can assist you with your product needs and repairs, visit radwell.com or connect with us on social media. Thanks for watching.
Digital domain. ADCs typically provide and the standard or SHBD compatible serial interface for connecting the audio or the analog signal chain to an MCU auxiliary bounce in to the MCU. The sire can sharpen the signal to an auxiliary using conventional filtering algorithms running in the software or on digital signal processing hardware for more performance-intensive applications.
The internet is shared critical infrastructure for everyone on Earth. It's not supposed to be a domain of warfare. We're not supposed to be putting our economy on the front lines of the battleground. But that's increasingly what's happening today.
You think about how the military looks at cyberspace today. They actually look at it as a domain of warfare, comparable to land and sea and the air and outer space. And they're looking at cyberspace as a way to both attack their enemies and spy on them, but also a place where they can be attacked and they can be spied on.
In fact, many cyber attacks occur without being noticed, and most cyber attacks occur without the government having any idea that they're taking place.
The advantage is always going to go to the attacker, because if you're defending your network, and let's say you're a large industrial company and you've got 70,000 computers in your company that are connected to the internet. That's 70,000 points of access that you have to defend against. The guy who's trying to get in through your system only has to find one, and frequently will look for a vulnerability in some software that you're running that you or even the manufacturer doesn't even know exists.
The American people have not yet decided what it is they want their government to do, or what it is they will allow their government to do to defend them in the cyber domain.
We're spending billions of dollars creating this new kind of warfare capability. And yet there's been no discussion in public about the strategy for using it, about the issues that arise in that strategy. So I think we would benefit by a public discussion now of the strategy involved with cyber war, but we're not getting it.
Conclusion: the cyber key can find analog signal conditional on conversion components with the performance specifications that can outreach the most the memory requirements for direct acquisition. For many applications, however, the signal chain can be effective in the memory application requirements with our requiring out the full complement of components of featuring the best possible specification beyond matching ADC to conversion requirements on signal conditioning component to ADC specification engineer can the sound signal change of the 2 years mobile performance on cost target. Thank you.